Hello friends, welcome back to the data structure tutorial, and today we will be discussing about deletion of a node from single linked list. In the previous videos we have discussed about how to insert a new node in the single linked list at different location, that is insertion at the beginning, insertion at the end, insertion at the middle of your list. Now if we want to delete a node from the element, we will be receiving one data from the user and we have to search for that data whether that data is present in the list or not. So if that data is not present, suppose for this example our data is 5, 8, 7 and 6. This is our data and user is asking us to delete suppose 77, which is not there in the list. So we'll be returning one message that data is not found. And if user is sending some data which is there in the list, we have to identify where exactly that data is present. So suppose user wants to delete the data 5, so the first node will be deleted, so the condition will be deletion from the beginning. If user is sending a data 6, so that will be the deletion from the end in this case, so we'll be writing and logic for deletion from the end. And if the element is in between 7, then we'll be deleting it from the mid. So all these three have the different conditions and we have to write the algorithm accordingly. So in this video we'll be discussing all the three and we'll be implementing also. So now I am writing the algorithm for beginning deletion of the node from the beginning. So I'll take the same example here. So we'll receive some data from the user, and according to that data we'll perform some search operations and then we'll be writing it. So let's say user has sent one data, that data is 7. User has sent one data and that data is 7. So what you need to do, you need to search the entire list and you have to find out where is the 7 exactly, at which address it will be. So this will be our starting address which will be pointing to the variable 700, address 700. And first of all, before deletion we have to check whether the list is available or not. So the condition is if my starting point, if my start is equals to null. So if my starting point is null, what it means, we do not have the list. So you will be printing one message, that is empty list. You will be printing one message that empty list, you do not have a list. Else if it is not the case, it means that you have a list. Okay, so we have the list and now we need to search for the 7. So you will be checking first node. If it is not there, you will go to the next node. If it is not there, again you will go to the next node and then you will stop. So to start that, you will be using some additional pointer. So I'll be using P and we'll be assigning the starting address to that P. So this will be my P because I have given an address of start, that is 700 to the P. So this is my first point. And what we'll check the information of the P. This is our information field as we have discussed in the previous videos, and this is our next field. So the information of P will be compared with the data, that is data containing the 7, and till then we will be keep moving. So while, you will be writing while P of info is not is equals to your data, till then you will be moving your P to the next location. You will be moving your P to the next location. Okay, so what is the meaning of this? So P is equals to start, so we assign the value of start to the P. So P is at 700. Okay, P's information, that is P's information is 5, so it is 5. Data is 7 and which is not equals to 5 is not equals to 7, so it will come inside. P of next will be copied into P. So this is current P of next is 500, that will be copied into the P. So P will be at 500. It will come back P's information, that 500's information is 8, which is not equals to 7. It will come in. P of next will be copied into P. So P of next is 300, that will be copied into the P. Now again it will check P's information, that is P's information is 7, so 7 not equals to 7, that will be false. So it will come out. So where is P? P is pointing to the variable 7 which user wants to delete. That is what the data we have received here. So what we are doing to this logic, we are actually searching a element. So here this is the logic to search the element. So this is the logic to search the element from the given list. Okay, and what if user, suppose user has sent one value that is 17. So I will be taking this data as a 17. So again P is 7, P's information is 7, not equals to 17, means not matched. So P of next will be copied into P. So P of next is 100. So this P will be moving forward. And now again P of information is 6. This P's information is 6. 6 is not equals to 17. So copy P of next into P. So what is P of next? It is null. That will be copied into P. So here after this P of next null will be copied into P. So P becomes null. And now you have not found 17 and your P is null. So if this condition appears, it means that that element is not present in the list. So you have to check this. So before moving forward, here inside the loop you will be checking if your P is equals to null. If your P is null, then you will be printing one message that not found, and after this you will be returning. So you will be writing return and if close. So this is the logic to check the element is not found and you will be return back. Okay, and else if the P is not null, obviously you will be keep moving forward. Now let us take the example of deletion from the beginning, for which we are going to write our logic, the entire algorithm. So I will be changing this entire things which we have written. Okay, so I have just removed it. Fine. So let us start. So let us assume that user has sent one data that is 5. Okay, no issue. So we'll be starting. You are coming into the else part because your list is not empty. We have a list. Start is assigned to P. So this becomes your P. And you are checking P's information. Current P's information is 5. Okay, so this is 5. And data which you have received from the user is 5. Okay, both are matched. Okay, so there is no need to move your P forward. So this is the node which you want to delete. Now let us assume that if you want to delete this node, who will be your starting point? This 500 will become our starting point. Okay, and we need to assign this address to the variable start, right? But where is this address? In which variable it is present? It is not copied in any other variable. So where you will find it? You will find in the P's next field. So what we'll write after this loop? You will be writing start is equals to P of next. So what is current P? It is 700. What is the P of next? 500. Where you copied into the start. So what is the new value of start? It is 500. So this will be your starting point. Okay, and you want to delete this node which is pointed by P. So this connection has to be released, right? So P's next should be removed. So how will you write it? P of next is equals to null, right? So let us write this entire list again. 5, this becomes your null because this is the 700, and this is your P, then this is your 8, this is 300, this is 500. I have mistakenly moved this, so I'll rearrange it. Okay, so this is 8, 300, 500. It is pointing to 7 whose next address is 100 and its own is 300. This is 6, this is null, and this is 100, and it is pointing to this. So as per our logic, P of next is copied into start. So P's next, that is 500, we copied into the start. So this becomes our starting point. Okay, and p of next is null. So p of next is null. Now this node is completely detached and this is your new list. So we have successfully deleted a node from the beginning of the list. So this else has to be closed here. Now we will be writing an algorithm for deletion of the node from the end of the list. So we'll be taking the same example for deletion of the node from the end of the list. So let us start. So while writing the algorithm, very first condition you have to check is if your starting point means start is equals to null. So it means that you will not have the list. So you will be writing empty list. And if you have a list, you need to search for that node which is to be deleted. So that's why you will be taking a separate pointer p which will pointing your starting point. Okay, so this will be your starting point and you copied the address of start to the p, so it is pointing to the first node of the list. And to search where is your data present, so let us assume that user has sent the data 6. So you want to delete a node which is containing the 6, that is your last node of the list. So while p's information is not is equals to your data, till then you will moving p forward, and before that you are also checking if p is equals to null, then you will be writing one message to the user that the element is not found, and then you will be returning back. And if the data is there, till then you will be moving your p to the next location. We'll be discussing this in detail. Okay, so what will happen? So whenever you are at the starting point, you are checking the p's information, that is how much, it is 5. Okay, what is your data? It is 6. Is it match? No. Whether p is null? No, p is not null because p is containing 700. So it will get out of it. P of next will be copied into p. So what is p of next? It is 500, that will be copied into p. So this becomes your p. Okay, then it will come back again. So what is p of info here? It is 8, which is not equals to 6. It will come inside. P is equals to null? No, because p contains 500. It will come out. P of next will be copied into p. So who is p of next? It is 300, that will be copied into p. So this will be your new p. Now again it will check what is p of info. It is 7 now. Now 7 will be compared with 6, which is not equal. It will come. Whether p is null? No, because p is containing the address 300. It will come out, and p of next will be copied into p. So who is p of next? It is 100, and p will be copied to the 100, that is 100 will be copied into the p. Okay, it will come back. What is p's information? It is 6. So it will take the 6, which is not equals to 6. It is false. So you have successfully found one element which is node which is containing the 6, and you pointed with p. Okay, now whenever you delete the element which is at the end of the list, what will happen? The previous node will become the last node after deletion of the last node. So the new list will looks like this. This will be 500. Okay, so this will be your 500. 8 pointing to 300. So this will become your 300. 7, this is 700, and this will be your starting point. Now if you delete the last node which is 6, the next field is null whose address is 100. If you delete this node, so 7 becomes your last value in the list, so whose next field should be null. Okay, this is how you need to rearrange it. So this 300's next field you need to make as a null, but you have not stored this 300 value in any of the variable. Last node is p, you know that. Starting node is start, you know that. But where is the 300? So how will you get the address of 300? So it is very simple. When you are on the 700 address p and you are moving to the 500 address, so you know that the previous node is 700. When you are moving from 500 to the 300, you know that the previous address is 500. So before moving forward, copy the old address. So what you will do here, this is the line you are moving forward. So before that, what you can do, you can write another variable, that is q is equals to p, and then p is equals to p of next. So what will happen here, whenever p is moving forward on this line, before that the address of p will be copied into q. So q will be here, p will be at 500, then this p will be moving to the 300, this will be q. When p is moving to the 100, this will be your q. So obviously q will be pointing your the previous node of the p, because you copied the address of p before moving forward. Okay, now queues next, you can easily make the queues next as a null. So after this loop you will have to simply write queues next is equals to queues next is equals to null. That is what we have done. This is your queue, queues next you made as a null, so automatically this connection will be broken and you have just written the algorithm of deletion from the end of the list. And this is the entire logic to search the element. This will be common for all element from the list. And now let us discuss about to delete a node from the middle of the list. We'll keep same example for the deletion from the middle of the list. So what will happen, suppose user is sending one data, that data is 7. So again you need to follow entire procedure, that is you have to check if your starting point is equals to null. I'll repeating it because it's a common for all, so that will be a good practice if you are writing it again and again. So it will be a empty list, it's empty list, else if your list is not empty, then you have to search for that node. So how will you search it? P equals to start, this we have written several times. Then you will be writing while loop, while p of information is not is equals to your data, that is 7 for this example, and till then you will be checking whether your p is null or not, to check whether the element is found or not. So this will be you, when p is null you will be giving one information that not found, that the element will not be present in the list, and you will be returning. Okay, and if it is not so, you will be copying previous address to the q, and p will be moving forward like this. And this entire logic which you have written is a logic to search the particular node, search the element from the list, element from the list. Okay, so p is starting point, so this is your starting point, I will be quickly writing it. Okay, what is p of info? It is 5. What is your data? 7, which is not equal, it will come inside. Whether p is null? No, because p is containing 700, it will come here. P's address will be copied into q, so this is q. Then p of next will be copied into p of next will be copied. What is p of next? 500, that will be copied into p. Okay, it will come back. Now what is p's current value? It is 8, which is not matched. Again p is not null, p's value will be copied into q, so this becomes q, and p's next will be copied into p, so this will come your p. Okay, now what is current value of p? It is 7, so this will become 7. So p of info is 7, data is also 7, so condition is false, we don't want equal, so it is equal, so it will come out of the loop. So we have successfully found the element which is to be delete 7, which is present and it is pointed by p, and the element previous element of the p 7 is pointed by the q. Now if you delete this node 7, how your list will appears like? So this will be remain your starting point as it is 5, the next address is 500, its own address is 700, next element is 8, next address is 300. Okay, and after deletion of the 7, this 6 will be appear after 8, so this node should be connected 6, this remains null, and what is the address of 6? It is 100. So instead of this 300, what we are expecting here now? We are expecting the new value, that is 100, because it is pointing to the 100, and the node which is pointed by p, which is containing the value 7, whose next field should be null. This is your P. This is what we want to complete after finding the P. Okay, so to do this, it is very simple. See, this is your Q. Okay, what is the address in the next field of Q? It is 100. And whether the 100 is stored in any variable? No, because you cannot assign 100 here. You need to find out where is the 100. So where is the 100? In the P's next field. This is the location where you can get that value. Okay, so what you will do after loop, after finding the P, you will be writing R is equals to P of next. Now look, you are copying the value of P of next into R. So this is your current P. P's next is 100. You copied it into R. So R is your last location. Done. Then you want to point Q to this R. So you will be writing Q's next will be your R. So this connection has done. Okay, and then you want to detach this node. So here you have connected to this R. So this connection is already discontinued because it is replaced by 100, and you have to detach this connection as well. So P's next should be null. So you will be writing P of next is equals to null, and you will be closing your else here. So this is the algorithm for deletion of the node from the middle of the list. And in the next video, we will be writing a code for all these three algorithms.